Synthesizing nanoparticles, methods and techniques. Synthesizing nanoparticles, methods and techniques. To produce nanoparticles, it is necessary to use specialized techniques. In this article, we will explore the various methods of synthesizing nanoparticles. Bottom-up synthesis. The bottom-up approach refers to synthesizing nanoparticles by assembling atoms or molecules together to form nanostructures. This approach can be done in a controlled and precise manner, resulting in uniform nanoparticles. There are several techniques used in bottom-up synthesis, including 1. Chemical precipitation. Chemical precipitation is one of the most widely used bottom-up methods. In this method, a salt precursor solution is mixed with a reducing agent such as hydrazine, sodium borohydride, or ascorbic acid. The reducing agent reduces the metal ions in the precursor solution into nanoparticles. The size and shape of nanoparticles can be controlled by adjusting reaction time, concentration, and temperature. 2. Sol-gel synthesis. The sol-gel process involves the formation of an inorganic network from a colloidal suspension called a sol. The sol is then converted into a gel by the addition of a cross-linking agent. The gel is then dried, resulting in the formation of nanoparticles. The size and shape of the nanoparticles can be controlled by varying the concentration of reactants and the drying temperature. 3. Hydrothermal synthesis. Hydrothermal synthesis involves the use of high temperature and pressure to form nanoparticles. The reactants are dissolved in a solvent and then placed in a sealed container which is heated to a high temperature. The high temperature dissolves the reaction precursors, forming a supersaturated solution. When the temperature is lowered, the reactants begin to precipitate, resulting in the formation of nanoparticles. Top-down synthesis. The top-down approach refers to the process of synthesizing nanoparticles by reducing the size of a larger material. Top-down synthesis is often used when the desired nanoparticles cannot be produced through bottom-up methods. The two most common techniques used for top-down synthesis are 1. Mechanical milling. Mechanical milling involves the use of a ball mill to crush and grind materials into smaller particles. The milling process causes the nanoparticles to shear, resulting in the formation of smaller and more uniform nanoparticles. The size of the nanoparticles can be controlled by varying the milling time, milling speed, and the type of ball milling equipment used. 2. Lithography. Lithography is a top-down method that involves the use of a patterned mask to create a pattern on a flat surface. The pattern is then transferred into the material using a chemical etching process, resulting in the creation of nanoparticles. The size and shape of the nanoparticles can be controlled by varying the size and shape of the mask used. Combination techniques. Combination techniques involve using both top-down and bottom-up approaches to produce nanoparticles. These techniques are often used to produce complex nanoparticles with unique properties that cannot be achieved through a single method. Two of the most common combination techniques are 1. Electrochemical synthesis. Electrochemical synthesis involves using an electric current to control the formation of nanoparticles. An electrode is immersed in an electrolytic solution, and an electric current is applied. The current causes metal ions in the solution to reduce onto the electrode,